Okay, so when we talked about this, when we started it, a radical is the same as an exponent that's a fraction. So your exponent laws apply. So these are just your exponent laws. So who remembers what the exponent law will tell you to do? When you multiply and it has the same base, what do you do with your exponent? So what do you do with your exponents? You add, subtract, multiply, divide. Which one you do? When you have two exponents. So if I wrote it this way, and I took away the fractions, what would you do with your exponents? You would add it, okay? Same thing, even though it's a fraction, we're still going to add. So when we add, we're adding two fractions. We already have a common denominator. So it would be x to the power 7/3. Okay, x to the power 7/3. This is your power. And this is your index. So what that means is when you see x to the power of 7/3, that means you're taking the cube root of x to the 7th. So how would that simplify? So if you have 7 people, how many groups of 3 can you make? 2. And you have how many left over? Just 1. So this will be your final answer. Okay, number 13. First, you're going to add the numerator. So 3 plus 7, only because you have the same denominator, you can add it. So 3 plus 7 would be 10. And now, yes. So the fraction rules apply. If you're fractions and they don't have the same denominator, you have to rewrite them with the common denominator. So 10 over 4, and now we would subtract, and that would be 10 over 4 minus 1 over 4, which would be what? So we have b to the 9/4. So again, that 4, that's my index. So that means I have the 4th root of b to the 9th. So these are the same thing. These are the same. So go ahead and simplify this. 9 people. 9 people, how many groups of 4? Go ahead and simplify that and then write what you would, how you would finish that out. So you have b squared, and then you have the 4th root of b. So this would be your final answer. Who had that for their answer? All right, any questions about 12 or 13? Pretty basic stuff. Monday, we start graphing, so you may want to have graph paper. I personally would just have a notebook that was graph paper and just write on it, but I know that some people don't like to write on graph paper. I believe it's homework 5 that needs to be done on graph paper, and I'll update Canvas so it says it, the one that has graphing in it. That's graph paper. Yeah. A grid is graph paper. So you can either print it offline or you can buy some, whichever way you prefer. Alrighty. Go ahead and copy down. Now we're going to get into some operations. So take a minute and copy this down. Okay, for multiplication, radicals can be different. For addition and subtraction, they have to be the same. So we'll talk about that. So for number one is multiplication. We can multiply them even though they're different. So for number one, we're just multiplying our numbers. So the coefficients, I should say. Multiplying the coefficient. So the number in front of the radical, that's called a coefficient. We can multiply those two together. So I'm multiplying 5 times -3. And 5 times -3 would be -15. And then we're going to do the same thing. We can multiply these even though they're different. Okay, so you can multiply the square root of 8 times the square root of 3, and that's just going to be the square root of 24. So I took the 5 times the -3, and then I took the square root of 8 times the square root of 3. So you need to look at that square root, though. Can you simplify that? And simplifying means I can take out a perfect square. So perfect squares are 4, 9, 16, 25, 36. Will any of those numbers go into 24? Yes. What number? 4. 4 times what is 24? Okay, so I'm going to actually simplify this down. And instead of the square root of 24, I'm going to write this as 4 times 6, yes? Okay, so it has to be a perfect square. Is 3 a perfect square? No. All right, so 24 has a lot of numbers that you can multiply to get 24. You can do 3 times 8. You can do 2 times 12. I think that's it. But they don't have perfect squares. It has to be a perfect square. You do not take apart a square root unless you're taking out a perfect square. So now, and the reason why... So I have this -15. This is going to just change to a 2. The 6 has to stay. So what I can do, now that I simplified that 4 down to a 2, I can multiply the -15 times the 2. So my final answer would be -30 square root of 6. So when you're multiplying or adding, make sure that what you have underneath the square root can't be simplified. Yes, did you have a question?
Yeah.
Uh-huh.
What do we do with the 2 in the parentheses? So is that because
Oh, right here? Oh, because the square root of 4 is 2. So the square root of 4 is 2.
So is that used because it's your middle?
Oh, you don't have to put parentheses. Is that what you're asking me? Why did I put parentheses around it? Oh, no, that's not necessary. If you want to just put it, you could just say times 2, like that. That's fine. Just know that you're multiplying this number by the coefficient, though.
So why do we take 6 out of the square root?
Because 6 is not a perfect square, and it can't be simplified. Yeah. So, your perfect squares, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. Those are called perfect squares. And if you can take out a perfect square from a square root, you have to take it out. So 4 times 6 is 24. 4 is a perfect square, so it became just 2. And now that it's a number, we can multiply it by the negative 15. Okay, but for number 2, that's different. Number 2 is addition. So for addition, you can't add these together. You can only add if it's the same number underneath the radical. So I'm going to write only. So for addition and for subtraction, you must have the same number under square root. So for multiplication, they can be different, but for adding and subtracting, they have to be the same. So what we need to do first, though, is simplify both of these. So going back to those squares that I listed off, let's look at them one by one, starting with that 18. What perfect square can divide evenly into 18? Now, I know I could do 3 times 6, right? 3 times 6 is 18. But it's 3 or 6 perfect squares. Okay, so we're not going to use 3 times 6. What else can I multiply to get 18? 9 and 2. Is 9 a perfect square? Yes. So I'm going to take this 18 and I'm going to write it as negative, because that negative is still in the front, and then 9 times 2. 9 times 2 is 18. Now let's look at the second one. Is there a perfect square that divides into 8? 4 times what? 4 times 2. So I'm going to take that 8 and write it as 4 times 2. So what I just did was I simplified the square root by taking out a perfect square. Okay, so now we have, this is going to change to a negative 3, because 9 is a perfect square and the square root of 9 is 3. This is going to become 2 times 2, because the square root of 4 is 2. So what is 2 times 2? 4. Now that they are simplified, they are like terms. So we can add them together. So this is the same as saying, if this was written as negative 3x plus 4x, because they're like terms, you would just add the number in front. That's exactly what I'm doing right here. Because it's simplified to have the same number. Now, if we simplified it and those two numbers were different, then we would be finished. There wouldn't be anything else we could do. However, in this example, we have the square root of 2. So they are what we call like terms. So negative 3 plus 4 is just 1. And it's positive. So my final answer is the square root of 2. Right. Oh, so, but you can't add, I think I understand the question, but you cannot, so we can't add the 2's. Is that what you're asking me? So I can't add the 2 plus 2. We can't add 2 plus 2. That stays the same. So that 2 plus 2, that's going to stay. We can't add that. It's just going to stay at 2. Then we would be finished. That's what I said. So if it was, for example, if it was the negative square root of 3 plus 4 square root of 2, and I think our next example may have something like that. We'll see. If not, I'll make sure I do one like that. Okay, so these are like terms. So I added them together. And when I'm adding the coefficient. So I'm adding -3 plus 4. And what is -3 plus 4? It's a 1. So I didn't put the 1, right? But isn't 1x the same as x? So do I have to put the 1? Okay.
You got me so mixed up. I get it now.
I ain't got no comments.
Yes, you do.
Okay, let's write down the next ones. Go ahead and copy these down. So you will have to make a box for number 3. So what do you think you're going to put in this first square? The square root of 5 times the square root of 5 is what? 25. It's the square root of 25. And what is the square root of 25? Is that a perfect square? So this is just going to have a 5 in this box. You cannot multiply these. So this is no different than taking a -2 times x. So it would just be -2 times the square root of 5. Because you can't multiply. You can multiply 2 square roots, but you cannot multiply a number by a square root. So this is just going to be -2 root 5. And then this square is just a +3 root 5. And in our last square, you have -2 times 3, which is a -6. So you would combine your like terms, and your like terms would be any numbers. So these are like terms. And because these both have the square root of 5 under it, see how they both have that 5? You can add those together also. So your final answer would be -1. And when you add these together, it's just plus. And you can put the 1, but you don't have to. Okay. So just square root of 5. And that would be your final answer. Did you have a question?
No, I don't have a question for you.
Okay, that's good. That's even better. Okay, let's look at number 4. Oh, you do have a question? Oh, okay.
So for the 5, the square root of 5 and square root of 5, we just multiply that?
Yes. And because, so you can multiply 2 square roots. You can multiply them as long as they have the same index. So you couldn't multiply, so if you have the square root of 5 times the cube root of 5, you can't multiply that. Okay, because these are different. This has a 2 and that has a 3. But you can multiply it if they both have the same number. And these both have a 2. So you can multiply it. So the square root of 5 times the square root of 5 is equal to the square root of 25.
Then you simplify that to get 5.
To get 5 because it's a perfect square. Okay. All right, let's look at number 4. Let's see what time it's at. 43. Okay. Let's look at number 4. Now, number 4 may take a little bit more space. So, can we simplify the square root of 3? Is there anything that I can divide? Is there a perfect square that I can take out of 3? No. What about 8? Is there a perfect square that I could take out of 8?
Yeah.
4 and 2. So I'm going to write this as the square root of 3 over 4 times 2, which becomes 3 over 2 times root 2. So I'm going to pause right there. So going back to, I think it was Appendix 7, where we talked about complex numbers. Remember I said that you can't have an I in your denominator? Same thing with a radical. So no radicals can be left in your denominator. So we can't leave this the way this is written. And the reason why is because of this square root of 2. This is a problem. So we have to get rid of it. And to rationalize it, we're going to multiply top and bottom by the square root of 2. So we're only multiplying, we're going to multiply the numerator and the denominator by the square root of 2. So let's go ahead and see what we get. So let's multiply our numerator. So if I take the square root of 3 times the square root of 2, what do you think we're going to get? Square root of 6. Good job. So I'm going to show all the steps. So there is a 2 right here. It's just a regular old 2 that's still going to be there. Now I'm multiplying the square root of 2 times the square root of 2, which is going to be the square root of 4. Now the reason why I did that is because the square root of 4, that's a perfect square. And what is the square root of 4? 2. So what I have is the square root of 6 over 2 times 2, which is just going to end up being the square root of 6 over 4. And no, you cannot reduce that. You cannot. You cannot do anything with that, because that 6 is underneath the square root. So you can't say that that's the square root of 3 over 2. You're done. That's your final answer. The other two go pretty fast, but number 5 takes a little bit of space. So remember I said that you cannot leave a square root in your denominator. So for this one, we have to multiply by the conjugate. And again, we have this in Appendix 7. So the opposite of square root of 2 minus 1, what do you think I'm going to multiply top and bottom by? Square root of what? Square root of 2 and what else? Plus 1. Thank you. So top and bottom, we're going to multiply by the conjugate, which simply means I'm changing out that middle sign of my denominator. The purpose is to get rid of the square root in your denominator. So this one takes a little bit more space, so I'm going to talk about, let's do the numerator first. The numerator is pretty simple because you're just taking 5 times the square root of 2 plus 1. But for your denominator, you will need to make a box. Because you're multiplying a 2 by 2. So take a minute and fill in, take a minute and try to simplify that out. So keep in mind, though, that you're multiplying like by like. What is the invisible number in front of this square root of 2? It's invisible. It's not there, but there is a number in front of there. There's a 1, okay? So there is a 1. That's what I'm multiplying the 5 by. So I'm taking the 5, because that 5 is a number. I'm multiplying it by the numbers, not by the square roots. By numbers. So I'm taking 5 times 1, so that becomes 5 root 2. And then I'm taking the 5 times that 1, which is just a plus 5. So now let's fill in our 4 squares. So we have the square root of 2 times the square root of 2, which is just the square root of 4. And what is the square root of 4? 2. In this box, you have a negative 1 root 2. You don't have to put the 1. You can put the 1. In this box, you have a positive root 2. In this last square, you have a negative 1. The reason why you multiply 2 conjugates is because the middle term will always drop out. So these 2 are dropping out. That's canceling out because you have a positive. It's like saying you have a positive x and a negative x. They cancel out. So you're left with your final answer for question number 5. And I'll have to take all this off, but I'll wait for you all to finish it. Is 5 root 2 plus 5. And that's all over what? What goes in my denominator? What'd you say? Just a 1, because 2 minus 1 is 1. Now, when you have a 1 in your denominator, do you have to write it? So you don't have to. You could also just say it's 5 root 2 plus 5. All right, I'll give you a moment to make sure you have that down, and then I'll clear it off, and we can get to 6 and 7. So for question number 6, so remember that the numerator is the power. Whenever you have a fraction, and the 3 would be a root. So what this is saying is take the cube root of 8 squared. That's another way to write that in radical form. And what is 8 squared?
64.
So what is the cube root of 64? So there is a number that multiplies 3 times to give you 64. So what number to the power of 3 is 64? 4. 4 times 4 times 4, because it's 3. So the square root of 64 is 8. But the cube root of 64 is 4. So your final answer is 4, because, let me write it this way. Because 4 to the third is 64. So if I have 3 people, how many groups of 3 could I make? Just 1. So the answer would be 4. Go ahead and try to do number 7 by yourself. See if you can figure out what that final number would be. I'm going to write it on this side. 16 to the 3/4. Okay. So what this means is you have the 4th root of 16 cubed. So in this example, it was easier. I mean, there is no order that you have to do it. So what I mean by that is it doesn't matter if you do your power first or if you do the index first. So I think for this one, because 16 to the power 3 is a big number. I don't know that number. Yeah, so I probably wouldn't do it that way. So what I would do is I would figure out the 4 through the 16 first. See, this power can move. It could be underneath or you can put it on the outside. And even for this one, we could have taken the cube root of 8, got 2, and then taken 2 squared and got 4. So there's more than one way to simplify this. It's easier for me, like I know the 4 through the 16. I know what number multiplies 4 times to give me 16. So for this example, it would be easier to do the index first. Because the 4th root of 16 is 2. And then 2 to the power of 3 is 8. So that would be my final answer. All right, that's our sign that we are done from there. We will finish out A10 on Monday. Have a good weekend.